Hello my fellow researchers, it's Jason here, and I'm going to make a quick video on the one sample T-test. And this is probably one of the most simple tests you'll ever do in terms of comparing means. And that's because, well, we only have one sample to deal with and one sample to do calculations on. So in this example, I have a sample of 9 individuals, so I'm going to indicate that right here. And these are depression scores, okay? So each of these individuals has been scored on a depression test. And this sample is actually of individuals who are all over the age of 70. And so my research question is there a difference between individuals that are over the age of 70 and the general population in terms of their depression scores? So I'm given the population average, and the population average is 40, okay? And that includes all ages. And then I go out in the world and I take nine individuals who are all over the age of 70, and I do this test with them, and these are the results. And now I want to see, is there a relationship between age and depression, or the other way of I guess phrasing it is do individuals over the age of 70 differ from the general population in terms of their depression scores? Okay, so in order to do that, we have to come up with a t-value. And then we have to compare that t-value with our critical t, or our threshold t. So the first step I'm going to do is I'm just going to figure out what is my threshold t. And so we know our population average is 40. We want to do a two-tailed test. We've chosen an alpha level of 0.05. And so you're going to look in the back of your textbook, and you're going to look for that t distribution table, and then you're going to find a critical t that's equal to 2.306. Okay? So that's our critical t-value. Now, we're going to solve for our calculated t-value, and we just have to find out a number of things. And I'm going to do it in this order because it just makes the most sense to do it in this order. And here are my formulas in case you forget, how to calculate certain things. But it's pretty simple. So first, the sum of x, right? You're just going to add up all these values. And you're going to get a value of 396. Okay, and I've already done these calculations, so I'm going to try and speed this up a little bit. Then you're going to calculate the sample mean, right? The sample mean is just the sum of x divided by the sample size, or n. So 396 divided by 9, and it's going to give us 44. Then you're going to calculate the sum of x squared, and so all you're going to do is square each of these values and add them all up. Okay, so 37 squared plus 50 squared plus 43 squared, so on and so forth, and you're going to get a value of 17,586. And then you have to calculate your sum of squares, and here's my formula for sum of squares, and thankfully I've already calculated each of these components, so you know the sum of x squared, we know the sum of x, and we know what n is. So when you just plug all those numbers in, you're going to end up with 162. Again, pause the video, try it on your own. Here is our formula for t. Okay, this is what you'll probably learn in school, and in this formula, we know m, we know u. We just need to calculate the standard error, and to calculate the standard error, all you have to do is use these two formulas here. First, you're going to calculate the variance using the sum of squares in df, and then you're going to calculate the standard error using the standard deviation and the sample size. Or you can do it my way, which is just a little bit faster. If you can memorize this formula, you can just skip all those steps, or basically just do them all in one step. So I have my degrees of freedom, which is just n minus 1, so that's equal to 8. And then you have your sample size, which is n, which is 9. And then you have m minus u, which is our mean, 44, minus our population mean, 40. So that's going to be 4. And then you can put a square root up top there. And then sum of squares is in our denominator, and there we have 162. Okay, and then you're just going to solve. And in your numerator, if you do 8 times 9 times 16, right, 4 squared, you're going to get 1152. And our denominator is 162. And finally, again, just to make everything very fast, I'll do this on my calculator. I'll type in 1152 divided by 162 equals. Okay, and then before I do anything, I'm going to push a little button on my calculator. It looks like this, y to the power x. Push that button, and then I'm going to type in 0.5. And then type in 0.5, and then push equals, and you'll get 2.66, and it goes on and on. what I did right here is actually just the square root. Okay, because remember, the square root of x is equal to x to the power of 1 over 2. Okay, so we get a calculated t value of 2.66, and it goes on, and you're going to say, okay, look, my calculated t is bigger than my critical t, therefore there is a significant difference between individuals over the age of 70 in terms of their depression scores in comparison to the general population in terms of depression scores. All right, that's great. We did it all in pen and paper. Now we're going to go right into SPSS. Here is the exact same data, right? I have 9 individuals. And we have the exact same numbers that we just had. All I'm going to do is go to Analyze, Compare Means, and then one sample t-test, because we just have one sample. I'm going to throw in that one variable we have, and the test value is where you put in the population average. Okay, so in this case, our population average is 40. All right, don't forget, our population average is 40. We're comparing our sample mean average, or a sample average, or a sample mean, to our population mean or our population average. Okay, so in SPSS, what you put here in test value, that's your population average. Okay, and I'm just going to hit OK, and this is what's going to pop up, right? The first table, it has our sample size, our sample mean, which is 44, our standard deviation, and our standard error. And again, you can calculate the standard deviation and the standard error using these formulas right here. This is the variance, but if you just square root it, you'll get the standard deviation, and then here's our standard error as well. You'll get the exact same values as what is outputted here. And then here we have our calculated t-value, which is 2.667, exactly what we calculated. Our degrees of freedom, which is 8, which is exactly what we calculated. And then we have our exact probability value for obtaining this sample, which is 0.03% approximately. So it's a very significant sample mean, right? It's very unlikely that we obtained a sample mean of 44 had there been no difference between individuals greater than, or individuals over the age of 70 and the general population. Okay, so that's why we're saying that there's definitely a difference, because it's very unlikely that this was due to what's called sampling error. Okay, or just natural discrepancy between a sample and a population. So finally, we also have the confidence interval here, which I'm not actually going to talk about because I didn't talk about it in this example here, but I will do another video on exactly how to calculate the confidence interval and exactly what it means as to a researcher. I hope you enjoyed this video. If you have any questions, please feel free to message me. If not, stay tuned for the next video in this video series. Cheers!